we are asked to match the function with the correct graph on the right. We are given g of x equals 1 divided by the quantity x minus 4 plus 3. Remember, the basic rational function f of x equals 1 divided by x has a vertical asymptote of x equals 0, because when x equals 0 we have division by 0, and the horizontal asymptote is y equals 0. Now looking at the function g of x, notice how the denominator is 0, or the 0 of the denominator is x equals positive 4, which means x equals 4 is the vertical asymptote of g of x. And since the vertical asymptote changed from x equals 0 for f of x to x equals 4 for g of x, we can say that g of x is f of x shifted right 4 units, and then because of the plus 3 on the end, the graph is also shifted up 3 units, and therefore the horizontal asymptote is no longer y equals 0, it is y equals 3. And now let's write g of x as a translation of f of x using function notation. To get the fraction with the denominator of x minus 4, the input for f would have to be x minus 4. So we can say g of x equals f of the quantity x minus 4, which would give us the fraction, and then we'd have plus 3. Writing g of x in this form, we should be able to recognize, because the input for f is x minus 4, g of x is f of x shifted right 4 units, and because of the plus 3, f of x is also shifted up 3 units. So let's also make a note of this. G of x is f of x shifted right 4 units and up 3 units. And now analyzing the graphs carefully, notice how these two bottom graphs both have vertical asymptotes of x equals 4 and horizontal asymptotes of y equals 3. But remember, g of x is a translation of f of x, where for f of x, one piece of the graph is in the upper right-hand region, and the other part is in the lower left-hand region. So the correct graph is going to be this last graph, where again, one piece of the graph is in the upper right-hand region, and the other piece is in the lower left-hand region. This graph here shows a reflection across the vertical asymptote. Let's take a look at a second example. Here we're given g of x equals 1 divided by the quantity x plus 3 minus 4. Notice now the denominator is 0 when x equals negative 3, which is the vertical asymptote of g of x, which means g of x is f of x shifted left 3 units, and then because of the minus 4, the graph is also shifted down 4 units, and therefore the horizontal asymptote of g of x is y equals negative 4. Let's also write g of x in terms of f of x. We can say that g of x is equal to, again, to get this fraction, we'd have f of the quantity x plus 3, and then minus 4. So because of this function notation, where the input into f is x plus 3, g of x is f of x shifted left 3 units, and then because of the minus 4, the graph is also shifted down 4 units. So analyzing the 4 graphs, this first graph is the only graph that has a vertical asymptote of x equals negative 3 and a horizontal asymptote of y equals negative 4. And the pieces of the graph are in the correct region, and therefore this first graph is the graph of g of x. I hope you found this helpful.